function.
Oh, right. So if you read the thing, it actually says it wants you to afterwards to check and make sure that the index is not swapped. So that's
Lab 7 or is input output. And you need to edit a file
so
or something.
your true statement actually should be behind another if statement after this.
Get lab 5
once this ends, so you another if
I didn't get
and all
lab
it's
6
going to test is
run.
making sure that index 2 is equal to.
You want to open up lab 6?
Well, what index 1 used to be. So that's what's a little tricky. You can't really do your check on that. I have initialized 2 different values. So,
Oh, build message is pretty bad.
Value 1.
That one's hard.
Value 2, so that's 2 for that. When I solve it, value 2 goes in the 1, goes in 2. And then you have to check.
One thing is like,
Yeah, that took me a while.
Like,
Correct, because you have, the only reason though is because you have to do a check on both of them, so you get.
Yeah, so it's not like you said.
Because you're trying to,
And both of those are equal to check.
um,
Then you check true. That's the check to make sure that they're not swapped. It's like
is this a definition or declaration?
Just, I would create another.
This is the
one.
definition, right?
Another,
You don't need the equals false because that's already in the declaration.
Oh, it's in the first one.
Yeah.
I just put like 10-1 to
Yeah, you don't need that either.
And that's fine, it's just, it doesn't have any checking. And you need to have your those values originally throughout in order to do the check.
I'm just gonna test it and see if
Expected comma or dot before the equals token.
I'm trying to think if there is a way you can do it. It's not in there. Value. I feel like there is.
Oh, you scrolled up too high. Yes, scroll down. There, it's right here, yeah. What is this? Okay, so
something.
expected comma or dots before line 86. Right here.
Well, I'm behind it.
Yeah. I said this something.
I also need to do line 6.
Oh, right.
Yeah, I think line
This
6
needs
is
to go back to space.
creating functions and terms.
Because that's a blank string.
Prototypes out of
And
Oh, so if you put a space in there.
this should be just one equals. Because you're assigning the value of this bool false.
So if you put like a space in there, it considers that a space and not an empty.
Should be your message.
Okay, try that. Okay, we've narrowed it down a little bit. Forbids comparison between pointer and an integer. 2 upper is a function. You're setting,
I know.
Where's your master?
How would I compare it to an uppercase?
oh, you're on get stacks, huh? Isn't there something called like is alpha and like is something?
Yeah, but it doesn't tell you if it's lower or uppercase.
Does it?
It just says if it's an alpha character.
Don't know how long. This one.
Maybe 2 upper and then in the parentheses. Well, no, it wouldn't work. Because that would just uppercase the letter. Have you seen the assignment 1 where you have to take in a string and capitalize the first letter, lowercase the second letter, uppercase the third? Yeah, I don't know how I'm gonna do that. I have no idea how that's gonna work. I mean, I'm just probably gonna say at 0, 2, 4, 6, 8, but he could break it and say, I want the index to be 50.
Can't you do like 2 separate for loops and make one like even and one odd and that shit?
Yeah, but here's the problem. When you pick specific index, what if he has an index of 50? You have to go all the way to 50, you know?
Yeah, but it's gonna float them all.
How do you check only for even numbers?
Like it's even or something.
Maybe. Because if there is, then that would be perfect. Because that would just solve my problem immediately. But I'm just wondering if those didn't exist, if, for example, like he typed in a string that was like 50 characters long, and you only go up to like 20 characters, it's gonna break. So that's what the coding assignment has the main for, is Luke will go in there and try to break it. And if he breaks it, then you fail. So that's why you have to test him before he does, because he'll try to break it.
My unit is gonna test off this. Not, it won't work.
Correct. Ampersand, whatever it is. Yeah. Would you prefer that we go back? So I did all the content, I think on 5, 6, and assignment 1. Would you prefer that I go back and do, or would we go back and do commenting on labs 4?
You don't need to convert it. Those don't really have many comments. And one thing I didn't talk about is that we try to make our function short. So basically your function comments should be enough to where you don't have to write comments like inside the main body of it. Unless it gets longer.
Right. Okay.
So the idea is if your function's gonna be like 10 lines or less, then write your big comments on top should say everything.
I see. Okay. Well, I kind of did both. We'll see.
Did you try writing value at it in labs 5? Lab 5, there's a function called value at where you check the value of a certain index, but you also have to check to see if the size is correct with the index. So if he tries to pull like index 8, but it only goes up to like 5, you're supposed to say it's out of range.
Well, why don't you just compare the size?
I've noticed that, like for using a constant.
That's what I did with the index. I compared the size with the index. And then I just outputted the value of that index, and then I said else set the bool to false, and then output false. Because, oh no, that wouldn't work. Yeah, I can't return false. I have to return an integer. I can return 1 or 0. Nope.
All right, we're gonna get going. We got lots to talk about today, and then obviously we've got assignment 1 due tomorrow. Labs 5, 6, and 7 due tomorrow. Tomorrow's a fun day.
Yeah, tomorrow is not my fun day.
Have you been working on stuff and keeping up? And tomorrow's just
Friday.
Yeah.
I got an exam on
But that's kind of
Friday.
what we have, the big stuff coming up. So I want to kind of get through our lecture today, kind of learn about what, right? Yeah, we've already done advanced info. We're going to do a little bit more with that today. A lab based on that. Today's lab's actually pretty easy. So that's kind of nice. I don't think I've been able to say that yet this semester. Today's lab's up, right?
Oh.
Yeah. You haven't seen it yet. You haven't done it yet.
No, I tried. Yeah, I got that.
So lab 7 is today, right? Lab 6 was yesterday. Does that sound right?
Sure.
And then lab 5 was last week, but then I extended it to this Thursday. So that's why, everything's all week. That's why there's 3 labs. Normally there's only 2. But we've talked a little bit about input. already a couple times, and we're basically going to reinforce that and say that we can use input not only from the user, right, via CN, but we're going to talk about how we get input, let's say, from files. So that's what we're going to look at today. Don't forget, kind of all the input and output that we've been doing them through these things called streams, which is why we include IO stream, which is why we include string stream, right? Those are both streams. It's a way for us to get data into our program and a way to get data out of the program. So streams is the flow of characters, right? We use this kind of water analogy of all this stuff. Input stream is flow of data into my program. Output stream is flow of data outside my program. So data comes in, right? And notice I say you get data from a user or from a file. So you get it from the console, you get it from a file, you get it from a string stream. And then output streams, right? The data's going to go out to the terminal or out to a file. Everyone good with that concept? All right, good. Right, and CNC out of both streams, they get defined in IO stream. We've seen that we can create string streams. The difference is CN and C out get created, right? Those are the streams that you'll use. For string streams, you have to create the stream, right? You can name it whatever you want. I normally name it SS for string stream. A lot of times I'll name it S out, right, for string stream out. So it works a lot like C out, right? When we get into files, we have a couple more terms like reading and writing. Reading is input streams, but input streams for files. Okay, and writing is output streams, but output streams for what? Files. They have their own include, so IO stream for C and C out, string stream for string streams, and then F stream for file stream. And that will give us our input streams and our output streams. So we include it, and then because they don't get declared automatically, because it doesn't know what file you want to connect to, we need to name them. And so we have two types. One is one's IF stream as a type, and one is OF stream, right? IF stream short for, what do you think? Input file stream. And OF stream short for?
Output file.
Output file stream. So hopefully that'll help you remember which one to use. That's the type. So FIN and F out, right? Those are the streams, okay? If these are types, right, those can be named anything. Think of them like variables, right? But we can name them whatever we want, right? Why do I name them FIN and F out?
File input, file output.
File input, file output, right? And they actually, what you'll see is they work just like what? CN and C out. So the nice thing is, once you set up the kind of structure of how we connect to files, it's really the exact same as what we've been doing with CN and C out. So you have to create the stream, but the stream has no idea what input file you're working with or what output file you're working with. So we use the .open function on a stream to say, hey, I want to open this particular file. So fin.open will open that file, right? Or fout.open will also open that file. It will look for that file in the same directory as your executable. Whatever directory your executable is, and which is usually the same directory as what our source file is in, that's where it's going to look for. Right? And once connected, you can actually read from it. So once I connect to my file, I can create some variables, and then I can grab from the file the first thing and grab from the file the next thing. Remember, the extraction operator ignores leaving white space and leaves what? Trailing white space. So when it reads, it's going to take the first thing to white space in your file and put it into this variable. And it's going to take the next thing to white space in the file and put it into that. Okay. The difference between CIN and FIN, right, is CN is going to wait for the user to type stuff and hit enter. A file already has someone that's what? Type stuff and has hit what? Enter. And maybe enter a lot of times, right? But it's going to just look in the file and see what it can pull in. Does that make sense? Output streams get opened in the same way, right? Big thing about output streams is it will create the file for you if it doesn't exist, or if it does exist, it will overwrite it. So be careful with output streams, because if you output to a file that already exists, it will delete everything in that file, right? Which is a good thing or probably a bad thing. So I can open a file and then, right, I can F out instead of C out, right? Strings, new line characters, all that kind of stuff. I can do it all at the same time. The nice thing is, once you create the stream, right, you use it just like C in and what? C out, right? And if you want to like set it up and not sure what your output looks like yet, you can just C out it to the console. And once it looks like what you want it to do, you can then set it up to write to a file. Because all you have to do is change the C to a what? To an I. That makes sense? Obviously, you have to, what? Open the stream, create the stream before that. But the syntax for writing out to a file is the exact same as the syntax for C out. Are we good with that? All right. I'm going to skip this slide. I don't like it. It's my slide, but, you know. We open a stream and connect it to a file with the .open function. When you are done with that file, it's a good idea to use the .close function to close it. We're going to open it, which actually connects your program to a file in the operating system. We're going to write to it or read from it, but when we're done, we want to close it. That way everything closes nicely. And it's just as easy as saying .close. So fin.close, fout.close. So we open it. When we open it, we say what file we want to open, but then that stream from then on out knows about that file. So when I'm done with that file, I can close it. And then if I want, now that I've closed it, what else could I probably do right after that? What do you think?
Open.
Open another one, right? So you can use the same stream for multiple files so long as you close it in between. Does that make sense? If you need to read from two files at the same time, what are you going to need?
Open.
Two streams, right? So now you don't have, right, fin, you have fin1 and fin2. I don't know, something to call, right? File 1, file 2. Does that make sense a little bit? All right, let's see if I can write code today. Is it going to be a good day or a bad day? So we need to include, so I'm going to include what? S-string, right? This looks a lot like IOStream, or looks like, no, it already was up. Right? And then I need help with using statements. Because we're going to use std, right? IFstream for what? Input file stream. And OFstream for output file. Are we good so far? All right. I have a file in the same directory called infile.txt. It's very lovely. It has 4 numbers separated by what? New line characters, right? So 4 numbers separated by new line characters. Right? And in main, I can create my streams and then connect it. So let's get some space. So I could say IFstream fin. I can say OFstream fout, and I connect them. fin dot open infile dot txt. I'm also going to say fout dot open. I'm going to name it outfile dot txt. It's obviously going to write out in plain text, so that's why I'm naming them .txt. You don't have to, right? You can name the file whatever you want. But that's what I'm going to output. So I do have a file called infile.txt, but if we look at our directory structure, there is no outfile.txt. Are we good with that? So there's an infile, but there's no outfile. What is it going to do? It's going to create one automatically for me, right? If it existed, it will overwrite it. All right? So first, second, third, I'm creating some variables here. Right, and I'm just going to say grab from my file first, second. Remember, one thing you can do with the extraction operator is you can pull in multiple things at once. So it says get from the file, grab the first thing to white space, put it in first, grab the second thing to white space, put it in second, grab the third thing from white space and put it in third. That makes sense a little bit? And if we look at our file, the first thing to white space would be what? 1, right? Because it's 1 and then there's a new line character. And the next thing to white space would have been 2, and the next thing to white space will be 3. So hopefully that works. All right, and I can see out. Right. first, plus second, plus third. So I'm gonna do that. You guys ready to see it run? Say, yeah, we're ready.
Yeah.
Of course. Or build it. Hopefully I didn't mistype anything. Right. And we get 6, right? Because 1 plus 2 plus 3 is what? 6. Now, that went to where?
The terminal?
Terminal, because I did C out. If I just change that C to an F, right, and we look at what happens now, right, notice my program runs, do I see any output? No, right, I don't see any output from my program. But, if we list my files, you'll notice that there is now a what? Outfile.txt, right? And if we look at it, right, you'll notice that what's in the file?
6.
Right? Because my output now went not to C out, but to F out. Normally a good idea that like you put out some other C out statement of like, right, file IO worked or right, we wrote to a file. That way the user doesn't freak out when they run the program and nothing happens. Right? Let's see. Right, out file exists now. Right, there's the 6. Right, just to reiterate that we can have whatever in it. Right, we go with that, and then when I run it, it's going to run, and now file's back to 6. Right, because it will erase everything in the file. Right, truncated is what it's called. Erase everything in the file and then start writing. Questions on basic file IO?
Does it always take the first thing you want space?
Always starts at the beginning of the file. So it will always take the first thing you want space. And once again, we're saying that's because you're using the extraction operator. Right? Because that's the way it works. Right? We're gonna apply get line, which we also learned last week. We're gonna apply that to get a full line from a file.
Can you tell it to look for specific things? Like if you want it to look for.
You can't, like, you're like, I want to go to a certain place in the file and then do something. There are, so there is a file pointer that you can manipulate and move around, but searching isn't so easy. You kind of have to start from the beginning and kind of search, right, to find what you want to get. Great questions. So right now, we can only write to the files and read from files, and it will overwrite the file. But it could be that you want to not overwrite the file, but you want to continue writing to a file, right? So that's the idea of appending. So instead of truncating our file, we're going to append to it. And appending is pretty easy, right? We create my output stream. I do the same dot open, but now not only do I pass in the file name, I have a comma, and then I pass in, right, this std ios app short for what? Append. So this says open the file for writing in append. So open the file for writing in append. And this dot opens a function, right? So data.txt is the first argument, which is the file name. Second argument is the flag, and this flag says to open it in append. That makes sense? Are we good there? Hey, look at all the file modes, right? APP is the one that we're really going to use, right? But you can open at the end. So 8 will open it at the end. You can open it in binary mode if you're dealing with binary stuff, right? You can create, so we've talked about output streams and input streams, IF stream, OF stream. You can also create just an F stream, which allows you to read and write in the same file. And then you can open those in input mode or output mode. There's also a couple things like only open the file if it exists, right? Or only open the file if it does not exist, right? So you can kind of say, okay, if the file exists, I don't need to recreate it. But if it doesn't exist, I want to create it, that kind of stuff. And then the chunks, the default, right? It's going to erase everything in the file. I've had students do this on accident. They'll put their .cpp file as the file they want to open for writing, right? So they wrote their source code, but then they what? They said that they're supposed to open their source or write to their source code. So the first time they run their program, what happens to their source code? So it goes away, right? So don't do that, please. All right, notice all mine have .txt, so you're not gonna overwrite your .cpp file. Don't put .cpp in your output or you might lose everything that you just wrote.
Unless you set that at the end.
Unless you do it for a pin, and then you get a bunch of garbage at the end of your C++ file, right?
You can program right your own program.
That's right, exactly. Can we write a program to write a program? We can. You can also, there's shorthand syntax to open files and create file streams at the same time. So for input file streams, this is the way that I just taught you. Create the stream, open it. You can also just create the stream and then open it at the same time. So if 2 lines bothers you, you can do it in what? 1 line. And if 1 line bothers you, you can do it in what? 2 lines, right? Your choice. I don't really care.
Why don't you need to open?
Ooh, good question. We're kind of going to get to that next week. But this is a class. Classes have constructors. So this would be the constructor getting called at creation. This would be calling the member function later. But we're going to get into that next week. We're going to do classes next week. And then no stream, same thing. Basically, we're taking the parens on open and just putting them on the file stream, right? And that's what we're doing. And it works for a pin syntax. Good so far? Okay, what's a big assumption that I've been making? Well, yeah, that's that is a problem.
It's got facts.
That's great. It's a good assumption, right? You made it this far, you at least know something. You know how to create a variable, right?
Yes.
Okay. Not as much for output, but what for input? What assumption have I made?
That there's something in the file?
Okay, good. Or that even more basic, that file exists, right? Because I'm going to write a program, but I don't really want to make an assumption that the file exists. My program depends on a file, and I try to open it and it doesn't exist. That's bad news for me, right? So I want some way of checking. Does the file exist? Does it not exist? All right? And so I'm going to show you how to do that. So it's pretty easy. The stream itself, if you treat it as a Boolean, will return true or false. True meaning the stream is working, i.e. it opened the file, and false if the stream is not working, meaning it what? Did not open the file. So you notice that here I open a file called stuff, and then I just have a simple statement. If not fin, meaning if this stream is bad, fin will return false, and the not will make it true, good. And so if the stream is bad, then I have an error, right? Input file opening fail. So the stream basically has a state associated with it, and it knows if it's working or not, and it will return true or false in an if statement, right? In some kind of Boolean expression. Does that make sense a little bit? So a pretty simple check to see is everything working or is it not. All right. You may also want to get a file name as a string, so not hard-coded into your code, but maybe you want the user to input a file or something like that. And it's not too hard, but you need to do something special. This isn't anything new. Create a string, create a stream, ask the user for the file name, get it. Right? Everyone good with that? That's pretty basic. Right? But here, when we do .open, we take the string and we have to say .c_str. Correct. Okay. File string things are old. They don't work well with strings. And so this converts my string to something that works well for the open. That makes sense? Or if you use the C++ 11, 14, or 17 flags, then you don't need it. But I don't have those flags built into my make files.
Is that the convert the string? Is that that means?
It looks like convert string. It actually converts it to a C string. So C strings are really the way that C++ and C work with strings. They're just basic character arrays.
Oh, I see.
And then strings, the nice thing we get to use, so things are a lot easier. Questions so far? Yeah, I'm just going to throw more at you. All the other things that we learned with streams that we did like last week and at the beginning of the semester, right, work with file streams as well. So I can use the .get function on a stream, right, and a file stream to get a single character. Remember, .get gets a single character, right? Get line gets an entire line, right, to whites or not to the inline character. So here instead of saying get line and cn, it's just get line and fline, right? Wherever you are in the file, read to a new line character, store it into the string there, right? That's what that says. Same thing though, if you're going to intermix the extraction operator and get line, you're going to mix those two. You need the dot ignore in between, right, to fix that problem. Bless you. So there's dot ignore, right? Remember we also had what? Dot peek. Right, so dot peek's going to work as well. All of those are going to work. You can also add single characters to an output stream, so you can dot put a character. We rarely do this because we can just use the insertion operator, right, the two less than symbols, and just put a character out. But you can do that. So dot put will do that. And the last thing that we really want to know about files is that files have an end, and that's actually really important, right? I want to know how many things are in the file, how far can I read, and so the stream can tell you when you hit the end of file. So the stream will tell you when you're at the end, which allows us to do things like loop to the end of the file, that kind of stuff. So .eof, it's a Boolean that gets returned, right? And it says EOF says true if we're at the end of the file and false if we're not at the end of the file. So you can write code like this, right? Should hopefully read pretty easy. While not at the what? In the file, get the next thing in the file. If everything's still good, and we're going to talk about good here in a minute, then we're going to put the next character, loop back up, and keep going. Okay. We'll get into the .good and why file input sometimes is a problem for us. But we'll get there. Let's look at an advanced example, because you guys are advanced now, right? Should I not make that assumption? Is that what you're telling me, right?
You convert a character letter into an integer. You do that again?
Static cast it. Okay. So if you have a character, you can static cast it to an int. Okay. Or you can just store it in an int, right? You can say int x equals.
Yeah, you said that before.
You can do int x equals a, right? And that will actually put 65. Now my brain's trying to figure out, what is he working on? I don't think I assigned it.
Well, that's how I can check if it's capital or not. I can say if it's less than this ASCII value.
All right, let's do some advanced data. Let's see, do I want to include anything else? We're going to bring in the C standard library. There might be something with that here in a little bit.
Does it slow your program down the more stuff you include like that?
Not really.
So I guess
So slow your program down, no. Remember we talked about last time with the preprocessor? So the more we include, the longer the preprocessor is going to take, right? And the longer it's going to take to package everything together at compilation time.
So that's why you don't just put everything under the sun right there.
Right, yeah. And then I don't want like collisions of like, oh, it's named this and this in two different files. What's going to happen? That kind of stuff. We just try to keep it basic. All right, there we go. I'm going to create a variable to hold the line in my file. I'm going to create an input file stream. Right, I'm going to call it fin, and I'm going to open a file at the same time, read.txt. So let's see what read looks like. Where's my arrow? Now it's broken. There it is. Okay, hide it. Here's my lovely 5.6 pickup stick, 7.8 ain't C++ script. That's my somebody I think saw that last semester. So I'm going to open it for reading. Right? Remember, this is all on one line. Create the file stream and also, right, open the file for reading. Doing that at the same time. I'm going to create an output file stream called fout. I'm going to open a file named append.txt. Right, and I'm gonna open it up in the pin mode, stdios. So let's look at that one as well. And look, there's the beginning of the rhyme. 1, 2, buckle my shoe. 3, 4, shut the door. So basically, I want to take what 5, 6, pick up 6, 7, 8, 8, C++, great. I want to take that data from that file and write it into this file. Does that make sense? That's my goal. Which should work because I've now added both, right, my input stream and my output stream. What's the next thing you think I should do? We should probably put it in a string. Okay, what? Even before that, though.
Want to see if the files exist?
Make sure the file exists, right? Remember, don't assume that the files are working. I mean, I showed you they were there, but we should also just make sure. When would you not be able to write, right? Reading makes sense, like I need to read from a file, but we know with writing, it will create the file if it doesn't exist. When might it not work? Anyone know?
Files are already being used when it's proposed.
So if the files maybe open in another program, it might not work. Or if for whatever reason you don't have permission to write to that directory, right? So there are times when writing will actually fail as well, but it's not as much. So remember I said you could not this, right? I'm going to show you another one as well. There is also a function called fail. So if opening my input stream failed or opening my output stream failed, right, then that's a problem. Everyone agree? And I can see out, right, one of the files didn't work. Right, and then I'm going to do this. I'm going to say return 1. Why would I return 1?
Because then it becomes true, and then it'll just.
So main is a function, right? Everyone go with that? That's where my program starts. Normally, what do I do at the end?
0.
Return 0, which, right, ends my program. If I return anywhere else in main, it's also going to end the function, which will what? End the program. And then any number besides 0 means there was an error. So I just chose 1. You can choose any number, right? And then you have documentation saying, right, an error code of 1 means that, right, a file didn't open. This will end my program, right? So the nice thing is, I put that in an if statement. I don't need, and we haven't talked about this too much, I don't now need an else statement, right? Last semester we taught you, write an if, right? Do stuff in there, the opposite stuff, put it in an else. Agreed? Right, and obviously then you get inside of curly braces, and if you do other stuff in that else, you get inside of more curly braces, right? Why don't I need an else statement? Why can't I just write code here and assume that the file was good and not bad?
Because it's only if it fails, it'll run the if statement.
So if it fails, it will run the if statement, and what happens in the if statement?
It'll end the program.
Ends the program. So to get here,
It just has to pass.
it has to pass the if statement, right? So here is, I'm basically in my else, but I don't have to write an else because my if takes care of the program being done. There's no way I can get to where my cursor is blinking unless the files do exist. Does that make sense? Right? So you can write it in an else if that's what you like to do, but I don't want to do that. All right. And now I'm going to say, while I'm not at the end of file, all right, I'm going to loop here. So now I can assume that the file is open. I'm going to say, while I'm not at the end of the file, I'm going to get a line from the file. Right? I'm going to get a line from the input file. Right? Put it into my variable called line. I'm going to app out my line, right, and new line. Remember, when you use getLine, you get the full line to the new line character, but what does it do to the new line character? Throws it out. Which is why now when I output that line, I add the new line character back in, right? Because I want it on its own. And then down here, see how, right, everything worked.
Oof.
I can do this. Everything worked, and then, right, the last thing I'm going to do is I'm going to close them.
Closed. It's okay, I type fast too.
I'm on that crappy little keyboard too. Does that loop make sense? while I'm not at the end of the file, right? And the end of file of whatever FIN got attached to. While I'm not, I'm going to get a line, and I'm going to output the line to not the same file and not the cout, but to my other file. Here's my input file read, here's my output file. All right, let's see if I made any errors.
Oh,
String was not declared. What?
which string?
Up here on my inputs.
Ah,
This is called a learning moment. So if you ever get that error, go up and make sure that you have actually strings on it. If you're gonna use it. It's always terrible error messages.
there you go.
There we go. It says everything works. Yay! So if I go back here and I go to read, it's still that. But when I go to append, it's what? The full thing. That's right. I don't. They used to have buckles on my shoes. Actually, I have some dress shoes that have buckles on them.
So the append will automatically go to the end of file and start writing?
I'll start writing. So I'm going to run it one more time, just so we see that. And you'll notice that, what do I get? I get it again, right? Because once again, it's appending, so it's starting at the end of the file and just writing down. If there was no, notice, everyone see the line 7, which means there's actually a new line character at the end of this. If there wasn't and it opened for writing, it would start writing it right here. So it's not going to add new lines automatically, right? It's going to go to the end of the file, whatever is at the end of the file, last character, and keep writing. Steve.
What's the point of the one that goes to the end of the file then?
Right, yeah, the one that opens
Yeah.
at the end?
Yeah.
I'm not sure. I mean, you could start at the end and then work your way backwards, maybe, character by character. Right. Right, yeah, that file mode or whatever. I never use that. I normally start at the beginning, just look. Great question. Everyone good with this so far? You have everything you need for your lab today, so that's good. I'm gonna give you more. More is better. Because you're gonna need stuff for your next assignment. So we talked about this a little bit, that, right, when I do input, the input comes in, but it's buffered. Remember I said I lied to you? It doesn't actually come in, it goes into a buffer. So all streams in C++ are buffered, meaning that it writes everything or reads everything to a holding place in your code and memory, and then it starts reading from that. And so streams are buffered, which means actually things don't automatically write when you say cout, don't necessarily get written to the console or to a file. They go in a buffer, and eventually what happens is they get flushed. Right? We're in this like water world with streams, right? They get flushed to the file or they get flushed to the console. And that's because that operation is heavy, as far as it takes a little bit of work by the CPU. So we don't do it all, every character by character. We'll take some characters and then flush them out to the console. Right? So this is a good thing for performance, right? But the weird thing that can happen is that if your program crashes after you did like a cout or you did a file out, it could be that it hadn't flushed it to the file yet, and so you don't get output. And so this will happen with students because soon I'm going to give you the power to crash your programs a lot. Right? Doesn't that sound great? Right? And so you'll write like cout statements to try to like help you debug it, but you'll never see the cout statement because it wrote to the buffer, but before the buffer could flush out to the console, the program crashed. And so you're actually in the wrong place of debugging because you can't see it. So we can force, right, stuff to flush. Right? There's a function on all streams called .flush. We'll flush the stream, really for output streams, we'll flush it out to the console or flush it out to your file. So that's, if you wrote something that's really important, you might want to do that next before you do anything else. Right? Might be a good idea. Another thing is endl, right? Adds a new line character, right? That's what we said from the get-go. It also does a call to flush. So using endls as opposed to \ends will make sure that things write out to a file or write out to the console. So they're good things to use every once in a while. All right, you want to go deep? So streams are classes, and I know we haven't talked about classes yet this semester, but a way of organizing our code. And so streams are classes, which is why they have things dot whatever, right? Dot EOF dot flush because they're part of classes. So these are functions that have been created that we can use. All right. They must be related because we said everything that you do with cout, you can also do with fout. You can also do it with string stream out. Right. So they're related in some way. And so we're briefly going to kind of talk about how they are related. I wrote something here to say, hey, you're smart. You figured out somehow they must be related. And so they're related through the idea of inheritance. So there's three big ideas with object-oriented programming and classes. That's the idea of inheritance, encapsulation, and polymorphism. And so inheritance is the way that these streams all kind of work together to use the same functions, but yet they're all slightly different, right? I'm going to write to a console. I'm going to write to a file. I'm going to write to a string stream area, right? This special area. Ooh, isn't it so nice? So this is the inheritance tree, right? And the thing at the top is like the start of everything, okay? And so there's a class called iOS base, right? And then there's a class called iOS that inherits from iOS base. And basically you can read it as it's the thing above it plus more. So iOS is iOS base plus what? More. Okay? iStream for input stream, OStream for output stream, are iOS plus what? More. Okay, and you might start seeing some of these things that you've seen before, like what? IOStream, IFstream, OFstream, string stream, right? I told you there was a way to read and write to files at the same time. That's fstream. You can make string streams that only work for input. Those are iString streams. We don't do that very often. We do a lot of times create string streams that we really just want to write to them. And so those are O string streams for output streams. One thing C++ does that most programming languages don't allow you to do with inheritance is you can do multiple inheritance, meaning that you can have more than one parent that you inherit from. So you'll see that IO stream inherits from not only iStream for input streams, but also what? O stream for output streams. But because iString streams, IF streams, IO stream, they all inherit from iStream. That's why they all have the same functions that they can use, because they all have the same parent that they've inherited. Does that make sense a little bit? There's going to be a quiz on this? Never.
Never.
But why do we care? Well, let's look at this. This is kind of like the function I made you write in the last lab, and you're like, really? You just want me to write 42 to the screen? Or return 42? Yes, that's what I wanted you to do. Right? So this function is called show. When I call it, what happens?
It outputs.
It outputs hello world, and where does it output it to?
Console.
Console. Every time I call this function, it will always output it to where?
Console.
The console. Which is good, but also a little what? Limiting. Right? So I can call it with show, and it will always output to the console. But we can use the idea that streams are related to make this function kind of work for more than just CL. So let's look at this function. So here's a function called show, but this time it has a parameter, and that parameter is a what?
An output stream.
An output stream, right? It's by reference because these streams are large, and you always want to pass them by reference. Okay. But now this function will take any output stream, and notice here's the name of the stream, right? Imagine that's cout, fout, all that kind of stuff, and it's going to write hello world. But now I'll write it to any output stream, so it's a little bit more, right, flexible. So I can do show and pass in cout. I can do show and pass in fout, and it will work for both of them because both fout and cout are output streams, so they're OS streams, and so that will work for me. So all of a sudden your code becomes more flexible and more robust because instead of writing a function that only writes to the console, you've now written a function that will write to anything that C++ knows how to write to. Files, string streams, and the console. Does that make sense a little bit? All right. So we had the flush and the strings and functions. So let's look at this real quick.
Is CERR or CERR different?
Ooh, good question. CERR, so that remember last time I said this function writes whatever to std out, standard output. Cerr writes to the standard error output, which both go to the console, but they are different streams, and you can take them and put them in different places on the operating system. So it's nice to separate.
Kind of keep your debugging stuff separate from the main outputs.
All right, what's going on here? Look at all these includes.
Oh.
Right? IO stream, S stream, S stream, right? The three that we have, and then a bunch of using statements so I can use this. So this is like that one we just said, right? Output, right? Takes an output stream and some string to write, and it will write it. So now instead of saying cout, right, and then some string, you can call output and pass in cout and a string. So we just kind of made it like a function. One that maybe is nicer is like, I made a function called readLine. So readLine is like getLine, but all we have to do is pass in, right, the string, where do I want to read it from, cin, fin, that kind of stuff, and it will read it for me. And then I have a bunch of stuff that's just, right, output's going to be basically like cout, read line from input, right, output to a string stream, read it from the string stream, right, output, right, to a file, and read from a file. And all it's really trying to show you is that you can use the same function for different streams because they're all what? Related. Does that make sense a little bit? I'm not going to run this one, but it's there for us to peruse. So I know at night sometimes you're like, I just need to look at more code. All right, and so you go online, right? Okay. No, is that not true? Am I the only one that does it? Yeah, I just browse through GitHub, look for something good. I have like 8 tabs open on my phone right now that are all like coding articles.
Oh God.
I know I'm weird like that. They're mostly all web development because that's what changes a lot.
We all have our vices.
Yeah, right, exactly. Mine could be a lot worse than that, I think, right? My vice is reading articles about code, and that's not too bad. All right, let's talk about flags and streams. All right, when we're in a programming class and we talk about flags, what do we mean?
An error. Right.
Okay, sometimes an error, but even more, what does the flag tell us? True or false. So it's some kind of like state. I'll use that. That's a programming word as well, right? Some state of my program. Is everything working or not, right? So that's the error, right? It's a flag for true or false. Did the user want extra input or not? Right? It's a flag. Right? So flags are a way for us basically to keep track of, what options are happening in my program. And so with streams, we have flags that tell us about the state of the stream, meaning did the file open or did it not? Were we able to extract the thing and put it into an integer, or did we not, or were we not able to do that? Remember we said, I know I hate it. Remember we said with cin, if I say cin and I put it in an integer and the user types hello world, it breaks. Right? So we need some way to know that it broke and some way of fixing that. And so that's where these error flags come in. Right? It's not just for file streams, it's for all streams. Right? And I love the names of them. We got bad bits, we got EOF bits, we got fail bits, and we got good bits. Right? We want the good bit flag to be on. Right? Meaning everything's good. Right? What's the bad bit? Something really bad happened.
Possibly.
Right? Some fail, perhaps physical error occurred. Right? Your hard drive broke.
Oh geez.
Right? That's not good. EOF we talked about a little bit. That's when you hit the end of file. You can also do Control-Z or Control-D. Control-Z for Windows, right? And Control-D for Linux. Maybe that's reverse.
Control-Z is Windows.
Okay, so yeah, Control-Z for Windows. So that will send the EOF bit, which is weird because you're not in a file, right, with cin, but it will send that and set that bit for you. And then fail bit is when an IO operation failed. 2 times that usually happens for us. 1, the file didn't open, right, because it didn't exist. The other one is, once again, you read from a file or you read from an input stream and you try to put it into the wrong type of variable. You can't extract it, so it breaks. Right? So the stream is still usable, meaning it's not bad bit, right? It's not failed permanently, but we're going to have to do something to mitigate the fact that right, we weren't able to open the file or we weren't able to read from the file correctly. Does that make sense a little bit? Each of those have their own function, basically. So there's a .good function, there's a .eof function, and there's a .fail function. Good means everything's working, right? EOF is, right, the EOF bit is set, and fail is either the fail bit or the bad bit is set. So we can get some information about it. And then we have a bad bit, and that's if just the bad is set. Notice that the good bit says true if the 3 error bits are not set. And so what happens, because computers like to talk in what?
Ones and zeros?
Ones and zeros. And so a lot of times with flags, we use the concept of binary to talk about whether something is on or off, right? And so, and I don't remember the order, but let's just assume there's a bad bit, a fail bit, and an EOF bit. I'm good with that? So if the bad bit is set, this would be a 1. If the fail bit's not set, this would be a 0, and if the EOF bit is set, that would be a 1, right? And so we're talking about binary, so we're looking at 3 bits smushed together, right, that give us some information. How big is a byte? Anyone know? 8 bits, right? And so this is 3 of 8 bits, right? So a byte allows us actually to set up 8 different things, right? As opposed to, right, if I say bool x, right, that only holds true or false, but that actually is 1 byte. So it actually is 1, 2, 3, 4, 5, 6, 7, 8. Right? So it actually takes up that much space, which is a waste of space. Right? Obviously, we have so much space now, we don't really care as much, but a lot of times flags get set up in binary as opposed to, right, 1 flag per byte. Does that make sense a little bit? And so notice I say good is true if the 3 error bits are not set. So there really is no good bit. Good bit is just the absence of what? All of the other bits. So if the EOF's not set and the bad bit's not set, then everything's zeros, which means everything's good. That make a little bit of sense? Right? So if the 3 bits are not set, then that's the good bit.
So you can manually check for those 3, or you can just check for a good bit.
Yeah. Exactly. So if basically you say not good, right, then it tells you something's wrong. Now, once an error bit is set, so if the EOF bit gets set, it remains set. So once bits get set, it won't auto get rid of it for you. But you can get rid of it. You can reset them with a function called clear. So if you .clear, then it will reset all of your bits back to what? Back to 0. Right? All of your bits get set back to 0. Now, if you don't mitigate the problem and you try to read from the file again, what's going to happen to the bits? They're going to get set again.
Oh.
But clear allows you to fix the stream, and then you can do something with it. So now good returns true. Most of the time we don't care about whether it's the EOF bit or the good or the bad bit or the fail bit. It's just, did it work good or did it not? And so one thing that's really important to know, and in fact, in your lab today, this is how I recommend you do things. The extraction operation returns the state of the string. And so the extraction operation will return true or false. So it's really weird, right? So I have it in an if statement. But that says, what? Get from the user, because I always do the stuff in the parens first, right? Get from the user a value. If that worked, then everything's good and the if part will run. If that didn't work, then it's bad, right? And then we got to do something with it, right? Fix it. Does that make sense a little bit? For us, in our lab today, instead of making an if statement, you could use that in a while loop. So you could read it as, while I can extract from the file, let's extract from the file. And eventually I won't be able to extract from the file, and that will be false, and then my loop will end. So I can loop to pull stuff in via an extraction operation, which actually is pretty cool, right? Because you can actually write the line of extracting in the same thing. So let's look at these bits, because they're kind of fun. I like this example. So let's look at it. So I have an integer called integer to get. Right? So I'm going to try to get a value from the user, and put it into my integer to get. And notice I ask the user to what? Give me an integer, and then I tell them to, right, and then I get it. Does that make sense? And then the next 4 lines will always be the same. I'm just showing you what value each bit is. Right? So good bit, bad bit, EOF bit, fail bit. So they'll give you values associated with it. And then I'll tell you the current value. So I'm going to read the state of my stream. And it will give me a number. And I should, from that number and what the base numbers are, be figured out what bits are turned on or not. And then I'll actually give it to you in binary so we can actually just see it. Right? Remember the binary. And then I clear it. Right? That's line 32 is an interesting one. Let's talk about that real quick. So what does clear do? Reset my flags. Good. Right? What's the next line do? It clears the buffer. Why would it clear the buffer? If I ask the user to give me an integer and they type in hello world, can it extract that into my program? No. So the fail bit gets set, but all hello world is still in my buffer because it was typed in and the user didn't enter. So hello world is still sitting out in the buffer. Well, if I don't want it there anymore, I can use what? .ignore.
Oh.
Right?
So it's like C and reader, but not really.
Yeah, and that's how we, if I had you write it, which this semester I'm not.
Yeah.
My next semester students get to write it. I switch back and forth. You guys lucked out. Because it's a bitch, but it's a really good thing to know.
At least he's honest about it.
Yeah, right. You're gonna write new cat, which is kind of sounds cool, but it's also it's only like, we're gonna talk about it next week, but it's only like 20 or 30 lines of code, which makes it sound really easy.
That's a lot of error
But it's
potential.
Ignore will go to the new line character, or this says the maximum number of characters that a stream can have. All right, so we take the size of a stream, the maximum size of that stream. Remember I said like just throw in 1,000 and call it good? Remember when I said that last week? Well, this is not the call it good. This is the maximum it could be, whether it's 3 billion or 8 billion or who knows what. All right, and so this will get rid of everything in the buffer. That way my stream is ready to go again. Does that make sense a little bit? Look at this line. Doesn't that look nice? So it says, please enter an integer, right? And this is basically making sure that the user will give me an integer, right? I will not continue on with the code unless the user gives me an integer. CN, integer to get, right? The user's going to type something. They're going to hit enter. If it worked, it will be true. And not true is false. And so do I run the loop? No, right? If they give me something bad, then not false is true. And then that's when it says try again, clear the stream, delete everything that they typed, go back and do it what? Again, right? And so yeah, for like C and reader, right, there you go. You have to type in an integer, right? This is code to say the user has to give you an integer value. Let's see if it works. It should.
Yeah. Everything worked.
Everything works. Did I forget to save it?
Probably.
You guys, it saves automatically for you, so.
That's a blessing and a curse, though.
Do you want me to give something good or something bad? Something bad. Okay. So remember I said when all the bits are off, that's the good bits value. So good bits value is 0, bad bits 1, EOF bit is 2, fail bits 4. Why does it keep going up like that? Because it's binary, right? Yeah, right. So 2 to the 0, 2 to the 1, 2 to the 2. Or if I had more, right, it would be 8, then 16, then 32. Right? Notice the current value is what? 4, which means which bit is set?
Fail bit.
Fail bit. And if you look at it in binary, there's the fail bit, right? There's the 1, because it's worth 4. This 0 is worth 2, because that's the bad bit, or the fail bit, and there's the EOF bit. Right? So you can see your bits and see, right, what the state of your stream is. I almost did it right on the board. All right, please enter an integer. Once again, hello world. Try again. No. No. All right. That and some stuff. No. One cool thing you can do, I don't know if you knew this or not, but if you type in what it believes to be an integer and then you give it characters, it will just read to the end of your numbers. And it'll actually throw the rest of it away for you.
Because that'll clear the buffer, right?
It'll clear the buffer automatically. So I don't have to do it. That's an automatic thing that C++ does.
Oh.
So notice my program did not stop until I did what? Integer number, right?
So it's like C and reader, but not quite.
I wanted to show, let's see, I'm on Linux, so Control D.
Try again. Oh, jeez.
I tried to send it in a file, but I must not be handling it.
How many times does that run?
See if I can do this.
Oops.
There you go. So I did Control D to send it in a file bit, and you'll notice that, right? This is what it gave me. Maybe it's Control Z, not Control D.
6.
So it gave me the 1 and the 1 for the fail bit and the EO file bit. The EO file bit got set. You notice that when the EO file and the file bit gets set, what also gets set? The fail bit. Because if you're at the end of the file, can you read from your stream anymore?
No.
No, right? And so the fail bit gets set as well. And then my loop freaked out, which is why I have to try again for free.
Is there a way to like kill a runaway program? Like if it
Control
just,
C.
Control C, yeah. Like if it just kept going.
That's right. Questions here? Can you handle one more little concept?
Sure.
Right. I think if you say yes or no, we're still going to do it. But if I get buy-in from you, then you'll just feel better. We're going to do this quick. There's also formatting flags. So we looked at error flags on streams. There's also formatting flags that allow it to write out in certain ways. And so that's what we're going to look at here. So one of the big ones is precision, right? Precision of outputting what? What thing will you output that needs precision?
Decimals?
Close, right? So sometimes students get confused. If I set precision and I output an integer, it's not going to add precision to my integer. If I output hello world, it's not going to add precision to my hello world. So this formatting flag only works with close, right? Doubles. Some kind of floating point value. All right, and so the two flags, and we're going to talk about them, are fixed and show point. That sets the flag, and then precision would then be how many decimal points do you want? You only get one decimal point. It's not how many decimal points.
How many integers?
How many right numbers after the decimal point? There we go. I can talk correctly. So fixed formats your float to be in fixed notation as opposed to scientific notation. All right. So let's just make sure that it's in the right notation, and then show point is going to do what? Show the decimal point, right? Yeah, you got it. There's a bunch of them, right? So we had fixed. There's also scientific if you wanted to output in scientific. This was kind of funny. Show pause, right? We're used to seeing negative signs in front of negative values, but we're not used to seeing positive signs in front of positive values. But sometimes you want that. And so put a plus sign in front of any number that's positive. I don't know what it puts in front of 0.
Positive, negative?
Positive. It's not negative or positive. Right?
You crashed the internet.
That's right.
You broke it.
You can also output in decimal notation, base 10. That's what we output in, right? Because that's how we look at numbers. But as programmers, sometimes we do things in octal or hexadecimal or binary. Because we read in bits sometimes. And those octal, right, 8, hexadecimal 16 has a correlation to binary. Much better than bits. And then if you're going to do it in other things, then you want show base to give you an O for octal notation or 0x for hexadecimal. So when you look at the number, you don't try to interpret it as base 10, right? You have to interpret it as octal or binary. Like, why does my number only ever go up to 7? Oh, it's an octal. You can write lots of flags at the same time using a pipe. You can get rid of them with unset F. So set F sets them, unset F gets rid of them. Basically, for us, the big thing that we're going to do with formatting is just precision. Or if you're writing stuff out and you need like precision of 2 because it's money, right, that might be a nice thing. You can also set the width of output, meaning that if you're trying to, right, output something, but it could be 2 characters, it could be 8 characters, but you want everything to be fixed the same width, dot width will let me do that.
Like word wrapping?
Yeah, a little bit, but like, I'm getting input from the user, and I don't know how long it's gonna be, and so I wanna make sure that everything lines up nicely. So this is more for like your GUI, although it's not graphical, your text-based interface table. So you could say dot width of 4, and when I output the character 7, but I won't actually get a 7, I'll get 3 spaces and a 7. Because the 7 takes up 1 space, and I said dot width of 4. So dot width says the next thing that I output, how many characters do you want it to be? So it'll look like that. Right, so automatically added it. Right. Also nice when like you output numbers 1 through 9, which are only right 1 column, but then you output 10 through 99, which is 2 columns, or 100 to 999, which is 2. If you want those numbers to line up nicely, then using something like dot width works well. Manipulators are words that you use inside of insertion operations. So indel is actually a manipulator. It's a function that does something, adds a new line character, and now we learned also flushes the string. Right? So both. Some that we use are set W. It's the same as width, but we use it inside the insertion operation. Set precision, same thing as dot precision, but we use it inside of an insertion operation. Meaning I don't have to leave my cout statement to run a function, right? I can just do it right there. So I do things like this. I output start. When I say set W of 4, that says the next thing that outputs will have a width of 4. So I output 10, but really what am I going to output? Space, space, 1, 0. Because dot width said that.
It obviously populates from right to left.
Yeah, by default, the spaces will be on the left. You can change it and have the spacing be on the other side, if that's right. And I'm going to set precision of 2, so I'm not going to get 10.3, I'm going to get what?
10.30.
10.30. And then I'll end it with a new one. All right. If I said set width of 4 and I outputted 10 characters, you will still get 10 characters. So it does not truncate. It only expands to, right, the minimum, basically. So width is really a minimum. At minimum, I want it to be 4 characters wide. But if you give it more than that, then it'll start spacing. There are ways to save the state of your formatting flags and ways to save the original precision of your formatting flags. So if you want to like save what it was and then change them and then put them back, not that big of a deal when you're using things like fout, because you created that string, or stream out, you created that string, but CIN and cout, remember, those are global variables because they're shared. You can use it anywhere in your program. So if you mess with it in a function, and you go back to main, it's going to have the same, right, stuff that you set up. So sometimes it's good in a function with cout or CN to save the original state, change it, and then set it. That make sense? Mm-hmm. All right. So there's sample code on that, but we're not going to look at it. Let's look at your lab. So in your lab, you're going to open a file for reading. That file is made up of basically numbers. All right, and your goal is to look at those numbers and decide what number it is and call a function based on the number. So if it's a 10, you're going to call the function on 10. You do not have to write the function on 10. I wrote it for you. You just say on 10 paren. Okay? If it's a 20, you're going to call the function what? On 20. And if it's a 30, you're going to call the function on 30. Does that make sense? If it's not any of those, right, 10 through 50, then you're going to call a function called on arrow. Right? Every time you call that function, it's going to increment a counter. Right? And so I know how many of each of those numbers is in the file I gave you. And so hopefully the counter will go up to the right number and you'll pass over. Does that make sense a little bit? So you get a string, right? This is the function you're going to write, process file. You get one string, which is your file name. So it will open that file, right, and make sure that it exists, right? So notice it says you're going to return true if the file name was successfully opened. otherwise false. So you're gonna open the file for reading, but if the file doesn't exist, you're gonna return false. If it does exist, you can just keep writing your program. Right? If you set that if statement. Question?
So you were saying that the on error will have a counter?
No, all of them have counters.
Oh,
So every time you call untend, behind the scenes it's gonna increment a counter.
the same one?
The same one every time you call untend.
Okay.
And so if we look at that file, right, here's this beautiful file, right? 10, 20, 30, 40, 50, right? And then a bunch of other stuff. So it's gonna parse the entire file, right? So it's gonna parse all 100 values. And at the end of it, I should know how many of each, right? There were 10 10s in this file, and 3 20s, and 40 30s. You know, does that make sense?
Yeah.
But you don't have to write the increment or anything like that. You just call the function on 10, on 20, on 30. Okay. Remember my hint was you can do an extraction operation inside of a loop. Remember that? You can do an extraction operation inside of a loop, right? Which we did right before this one. Maybe. Oh. It was. We were there, right? Remember I did an extraction operation in a loop. Right. So you can loop while you extract, and it will keep pulling in stuff until the stream dies, which in our case is at the end of the file. Make sense? You can pull them in as strings or as integers, your choice. Just make sure if you pull them in as integers, you compare them to integers. If you pull them in as strings, compare them to strings. You can pull them in either way. But today, right, I've been having you write like 5, 6 functions. Today you're writing one function, one if statement, and one loop. So it should be a little bit less, which is good because you have a coding assignment due tomorrow. You have labs 5 and 6 also due tomorrow, and then lab 7. That seems like a lot. I kind of feel bad too. Just a little.
Kind of feel bad a little bit.
You've had the assignment for like 4 weeks, so I don't feel that bad.
I'm not worried about that. What about the other stuff?
The other stuff. You're used to it, right? Oh, I should say this, just in case this is you. If you're going to choose to not do your assignment or not do one lab, I would choose not doing one lab to get your assignment. And you're going to have 5 assignments this semester, and you're going to have 26 labs. So you can hopefully do the math. I'm making an assumption here that you can do math. And you can also look at those 2 choices and decide, if I need to work on only one of those things, I should work on my assignment. Right?
Yeah.
Yeah. I also dropped one lab, so.
Oh.
But that's like, if you're like sick and you can't come in class, that's really what that drops. But you can use it for whatever you want. People like to burn through their freebies at the beginning of the semester sometimes. And you can. Okay. So we'll go back into our folders. Just like before, and then just like before. So Nate runs it with the driver. You can set up. Yeah, that's just. There's also one base.
Which is fine. Like that's because I would only have access on whatever device. So when I was actually at your home, then I wouldn't have been able to work with my phone.
Yeah.
Which,
It's in there.
so, like, this is just, yeah, this makes it easier for now. Yeah. Well, no, it probably would have been like,
Otherwise,
just Still.
So yeah.
And then I don't like the library. If you want to use it, you can, the driver's computer, you want to make your own test for your functions.
I'm sorry.
That's okay.
And that's what it defaults to.
We got the robot.
If nothing else, it's gonna.
Nice. It's not raining right now either, right?
No, this afternoon, I don't see your office keys.
They're on my phone.
That's just where we're going.
Oh, you didn't.
That's just.
Is that monkey? That's the biggest perk about being shared.
You can like pass in your own variables to your own function and see if it works.
Thank you.
Here.
Right now, there's a card. Under clean assignment. I started on lab 6, but I realized that.
So something I did
did.
and string is away. So you can't create an all the things something like that.
Yeah. Is that how you would do every other one? I was trying to tell it.
Good,
The
yeah.
other?
Because the easiest way to do every other is mod. You mod something by 2, meaning you divide it by 2, right? Either 2 will go evenly into a number, or it will go odd into a number. So if the remainder of mod was the remainder, right? Remainder is 0, it's an even number. And the remainder of 1 is odd. Does that make sense?
Would that work too?
Problem?
But I understand it's not highlighting anything. It was other things.
I think so.
Yeah, I'll come over, I'll bring it up.
I don't find them
Okay.
full blind paper. I mean, that's literally my other account. That's what I promise. Yeah, that's what we had. It's kind of the thing that my mom literally just says, oh, he doesn't want to provide it at each class. He wants to retain account. And then it has line failed. It must be from the user provider. User provider. User provider. So the device number 2 plus.
So we I call this function average. Approximately an array. So it's saying that yours doesn't match up to that. And so we look at your mean average, right? And you go backwards. This is now the size and then the array. It's supposed to be the array size.
Oh. Do we?
Yeah, pretty good thing. Here as well. Oh. You'll have to fix these warnings.
Okay.
But it does actually compile to
Wow.
I'm not doing anything today. The unit test will show you, right, what yours is and then what mine is. And so your number should match my number. So now you just know what one is now. Okay, so why is count carries the front line when I'm going? If it is 0, 0, and 1. Why is that wrong? These parameters are by reference. I mean, the ampersand one. Because they're my counting things. The function's void, you're not returning anything, so the only way for me to get something out of it is to make those by reference.
Okay.
So do that, and then the other end is that you can't start counting from unknown values. So before your one, you set letters and numbers to. And then now hopefully you should get your first one.
Well, then
What do you got?
So, how do I do it?
So just make unit test. Yeah, make unit underscore test.
Oh, that one.
Make space unit underscore test. Yeah, it's in the, it's in the instruction.
Yeah, but I can never get thrown for this.
In the PDF where you got all this stuff. That's where it's at. Yeah, how did you know what function you're supposed to make?
Oh, it's on.
So that works. It says maybe I'll include.
Oh.
Yeah. Gotcha. Yeah, you're like, oh, just put it in there and see what happens. Never includes it. I'll run the unit test. I guess, not bad.
Oh.
Yeah, that's fine. Array of thickness. Array of thought. I'm working on a game, trying to make it as easy as out of there.
No, I gotta be like, so.
We already done.
Well, no, I've tried it done before, but I think I'm used to get that desktop. Well, that's something that we're gonna be working very well. We're gonna do it. Oh, that's
Okay.
Sorry about that.
So my driver went, is it, I was online, right? I just wrote that.
Yeah, because I've been using driver to test out my.
Yeah.
Yeah, I was doing it through the driver.
Well, the driver's good. I wanted you to go do the driver to test your own stuff. And then test with mine and see how well you actually did. How good of a test did you write?
It's like very, very basic, like, oh, we can put in a string and see what it comes out.
Right?
Okay.
That, and
Uh-huh. Well, but don't recreate them. So you already created them here, right? You already said that.
oh. There goes,
And you do it in
okay.
you have like both places now that. Now this thing will get then they go to one little icon and that's like they can just start on the I just have to up there. Make it again.
Oh, great.
So yours says 05 and it says 50, this says 50, it says 05, but just like that maybe. Yeah. I bet you, right, I bet you,
Well, there's plans. Yeah, we're gonna get up on the.
my guess is that this is that letter.
They would be suspicious.
So whatever order I had it in PDF, that's like, I need to be in that.
It's not there in, yeah, there's not.
It's the right order, letters and PIN number. I passed all that. So, one function totally done and working. So now the up and down. And what's up?
Yeah, how do
Take what the next round is. Not letting you do it. But that is literally not working. This would be, right, this says that whatever index I'm on, this starts at 0. Now the weird thing is that even index is where the first character is on here.
So then you put that in
Yeah,
there.
yeah.
Okay.
Make it look awesome. It does. Oh, this is now. It does. There is about get 100. Yeah.
Oh, baby with. Technology, all this some of the things that I can quickly.
So I don't think this needs to be fun.
Yeah, but it will be fine. I'll leave it fine.
And you're sure. Pass down. I think I did string pass. Use the string for nothing, just out of it. If you're a component.
The program never told me it was like that. It's just normal for the test.
Yeah.
Oh, yeah.
But that's it's tests
Yeah.
Never
Now you're all, everything's all good. It should work when you get full class now.
It's still ambiguous. Yeah. How do we use the
So those are basically you're gonna have to recompile. And you just use the track.
still ambiguous?
And go file. Recome the file, put it in the variable.
Oh, wait, I thought 220.
So get the single character, and that might not work because we're writing the numbers on it. Get line will get the line, which works. So you can test it.
And then get road lines.
But it's, how do we get people like
Wow. And then write the alpha just be called.
So, anytime it's.
Oh, yeah, you just call it on. Yeah, it's like that. Which is behind the scenes, it just means making a calculation. What? Which actually?
No, I said in the first one. First,
Just the first one?
yeah, it's like the first, and all of them, the first.
Oh, but
It's
it's
a boy,
not.
it's a picture. What you're doing is you're modifying the two values.
If I modify.
So whenever you input, so I just did as long as they're,
So you're supposed to call it. It's, wow. Yeah.
Oh, I didn't see that.
Another.
I
don't. It's kind of like a bunch of ifs. Wow. That sounds like fun.
That's basically, because if I reference anything, you can recite the code, we'll change it outside. So you don't need to, if you don't need to.
I misread that. I forgot.
I thought it was gonna be, you run.
Oh, there you go. On to the next one. Your answer that one is, you're always trying to zero, so your answer is always zero. Count, I might want to return it.
Oh,
Right?
Lord, yeah, maybe.
Okay.
So that was.
Yeah, that's always a good idea, right? 'Cause you never know what I'm doing.
Oh.
Yeah. So when we get that, there's a way for us to see like where in the code it was. It's like parts. And then you're gonna say one here. Maybe crash. Oh, wait.
Okay, yeah, are these supposed to be counts by reference? Oh, okay.
But it matters that it has to be after the string before they identify it in there.
Just kind of one question, the word that I use before you put the string. Am I seeing it if word is greater than zero, I'm saying if word is not empty. So, I've realized that it's not comparing.
Zero can still be, zero, well, it doesn't mean that's not the point. So the easiest part, the easiest way I can think of it, so you would do, this is your string, so you would do equivalence, so that's and, that's just an open and close, parentheses, right, empty space. No, I'm sorry, not parentheses, quotations.
Okay.
Now, the thing is, this is true if it's empty, you wanna make sure it's not, so if you put an exclamation mark at the end. Actually, I'm sorry, exclamation mark equals. It's not equal. So now this will run, this will be true if it's not.
That's what I'm missing.
Yeah, that's what I'm missing.
So I think this one we're gonna kind of do this because I'm trying to.
Slowly trying to figure it here.
Normally I'll just go in and I'll just.
Guess I'm so used Yeah, that's what happened to me.
Okay, so I was doing. There's only warnings, which I'll have to fix eventually. You've gone from passing 6 to passing 29.
So far,
And it's because you made an assumption.
You're looking for why operate.
So your else should be an else if is upper.
It wasn't a plus. Does that make sense?
Because it doesn't
This guy, right? Yeah.
This guy for coffee, so I'm kind of trying to use the same when we're searching for the value.
So this value is not anywhere below just given value equals.
So yeah, it fails. I don't know if it's.
Okay, I'm asking for your save.
So you would go the string name, dot size.
yeah.
That returns the size.
Okay.
I don't know if it returns as an integer though, if you have this float or something.
Yeah.
It should be an integer. Oh, yes, it does. It always returns a positive unsigned integer because the size can't be made in a negative string.
Yeah.
It can only be 0 or positive.
So basically, if I did return words outside, it would count the number of characters.
Yeah, exactly.
But
Just return word
but I guess I'm feeling is gonna have issues because I'm not using these variables.
I know that.
Because basically what I'm doing
At least one
is I'm just asking.
Yeah, because your terminal number is gonna enter after the first.
Oh, no, what's important is it's not any characters, it's counting the uppercase and counting the lowercase.
Oh, okay.
So you have to switch to alphabetical errors. Or, sorry, not alphabetical, it's counting alphabetically. So the bullshit we can do this is because they change like this. Yeah. I have to try and use the function.
I just want to.
So yeah, the tricks to those are,
It goes through and looks for spacing.
that's how you test to see if that puts what's in there. So you can try.
I don't understand. So your issue. I think when you're counting.
Every time that you grab the file, right, the track number it says, or the integrity, it has to be from the file.
Almost the same.
My hint to you here is that when you do it this way, what will happen is that you make it to the end of the file. But then it has to extract one more time for this update of it. It doesn't know what's updated now, so it tries to. Well, what's happening is that so you call them errors. No, the on error is saying if it's not a 10, 20, 30, 40. So it's just like your catch-all.
Your word count is a space. There's no plus one.
Yeah, so a lot.
Instead of just checking if it's
So what I do is I can just,
no, checking.
while I can extract. And then we'll do it once, we'll do it, and I'll tell you what, as many times as it needs to do it.
Anytime you space it, so when you give a number, yep. 30.
There's a lot of spaces.
Well, no, you're gonna count, extract once.
Yeah, the file name dots. They fixed it in single plus a lot, and I'm just not. What do you got?
Just started working on those.
So you want to use it for anything, you use it for anything, right? It's going to be a volume. So they're going to, so RB is going to get set up. So RB will automatically. RB will automatically. So you can make a vector with it, that's fine, but then in the vector, you don't want to save it one by 60. You're just going to open it. Because whatever file name they type change, you know, open that file for you. Output it. You don't have to know anything. You just use RB or RB. So these are if so you'll run the program new cat space 1.csv. New cat 1.csv 5.csv. New cat so it should open any file, including the fact that it's saying he's got class on going. Oh.
So the deal is more basically a lot of those,
It says like, because it says that there's like an error online.
Yeah, I know.
No. You're not making, I'm just building it without you. When you include the CPP, it really is just a CPP. And I'll say no. Except for this weird slash on the side. I'm gonna close it. We're going there and open it again and be like, oh, look, there's a.
Sometimes we get signed up on something that you're quick, but it won't.
Now back. All that. Ready for it? I think it's gonna work.
Okay, so I can see like the string and
You can use the string buffer, you use string number app.
No, I know, I'm just trying to think, I did it last too.
Probably not, you probably had it, and then probably when you're deleting stuff to like mismatch it back together.
Oh, that would be, yeah.
It is, so what's happening is that, one entry on. So last time, so here's your file.
Here's your
file. It's like 10 minutes, and then really there's an EOF, right? And so one's gonna get pulled in, right? And then 10's gonna get pulled in, and then 20's gonna get pulled in. So those all work. And really you're done. But what's gonna happen is it's gonna do one more, and it's kind of pulling nothing, because it'll set an EOF there. That nothing is gonna call on there, which is not actually, but you don't want it to call on there, you just want to use it. It'll work, although I don't let you call on there. So my recommendation is that instead of doing your extraction operations, the while so this is just saying, while, basically read it as while we can extract from the file. Last time we do it, right? Now it's something in the file.
Except it's like, except for the silver. Graphically, it's insane. I can see it.
Yeah, so take this and a number and just put it as the condition. So I'll write on the board. Say while, and then extract into your number. That's what your loop should look like. Because then it will extract for however long it needs to extract. And the last time when it can't extract anymore, then the loop will end.
I'm trying to use this digital.
Okay.
Yeah. Is there like a key or something?
Well, this digit code is digit on a string,
Oh,
and this digit only works on the.
okay. So what I need to static cast it?
No, you need to pull in that specific digit. So you're in a loop, right?
Yeah.
So do word dot add.
Okay.
I'm trying to figure out this last one. The one thing that's wrong is the text. It's just in space, and I can't get it to say 0 words.
So you start the count at 1, right?
Yeah.
So then just handle that specific 1, right? Well, fine.
You're starting to count at 1?
Well, it says the string will never have multiple spaces between lines. So it doesn't actually have a space, it has nothing, right?
Why?
So you're just gonna handle that specific case. So when it's empty, so right next thing, right? If words equals the empty string, just return 0, right? No words. So you just have to handle that specific case.
Okay.
Or you say words dot length or words dot size equals 0, I mean, there's lots of ways of it. And put it parentheses.
So it just runs around the house.
And then you're done, right? Because that handles the one off case.
Right.
Yeah.
I
know, just debugging.
Well, I can tell you that it's gonna start your first function. So it's gonna be something. Always less than size. All. Okay.
What?
Wait, why would it be less? It would be, no, it would be less. Oh, no, no. let's make it fly.
Oh, you're not in that function. You wrote all the code, we write the function.
It still works.
It's a function definition.
Yeah, it's super fun.
I mean, you don't even necessarily.
Yeah, it's so this is already fine right here. So it's that.
Not use upper, it's Does that make sense? So a space, a space returns false for its upper. It's a version control system is really what it is. So I'm using it for submission of assignment, but really it's version control. So it's fine if you have multiple versions. Then you'll just work on the next one, and then you guys go back.
Well, I mean, so what I know is.
So get into your assignment. So make does it with your browser, make space do that. A lot. This definition declaration.
Inside my function.
It's like cool.
Oh yeah, because some takes the values. So what you would do when you return
But I think you're right. We got time on this. I have to change it. I think we're
That's like a lot.
trying to do this. You can, as long as you can. So what we need to do is space. I has to be smaller than.
Oh, that'll be easy.
So your issue was your increment, without that, your increment's allowed to just go on. This is what stops you on this summer season. It is, yeah. Where's the final name? I was doing that inside the same line, but it works. There's no reason.
Yeah, I think it's like,
Yeah, you're Oh, yeah, I did a lot of
I'm assuming that's not up there.
You spoke what?
I was sure thinking it was like developers who go around.
Yeah.
Yeah, so.
Oh, no, I just go in and I write it down.
Is this index numbers not straight out of
Index will be generated by your phone. Because you basically.
Oh, so string is
correct. Yeah, you basically do that. And then you would compare like word dot add. Sorry, word dot add I, and then equivalency, so equals to upper, inside those parentheses, word dot add, inside those parentheses, I. So basically, you're returning itself to its upper version. It was already.
So
No wonder it wasn't.
I open this part.
And basically, if that was false, it won't run any of that anyway. If basically you didn't have that, it's still gonna try and run this. You know?
No, I meant that first.
Okay, so if you go back, so we'll already do this. Sorry. Okay, so this is your for loop. So you don't want this part to be for loop. That's just going to be an if statement inside of it. So your for loop is just basically going to control the index and how far it goes. So in this case, sure, I would do that. The and part, I would go index cannot be greater than word dot size.
No, actually, that makes sense.
Yeah, you don't want that. That's what you want.
Yeah.
You still wish it would like.
Word dot size?
Yeah. Yeah, but so the beginning of this would be I is less than or
So when this still work,
the problem is, yeah, you don't want to compare it right now, you're comparing it to whatever element you're looking at.
It didn't bug me.
Yeah, you can do that. Yeah. You're doing drop down?
Yeah.
So, yeah, so well, so here, it's kind of logic thing. So, what you're doing is you want to take a string, like 5 characters. So the first one would be capital, the second one would be lowercase, the third one would be uppercase. So you're going to have 2 for loops. You're going to have one that goes through it and takes the first one uppercase, it skips the second one, takes the third one uppercase, and skips the fourth one.
Yes.
So if you're incrementing by 1, you're going to make it all uppercase. So the trick to that is, yeah, it's, I think it's, basically the idea is you want to increment by 2. So, because you're going to make the first one uppercase, save it, and then you're going to skip it, the third one uppercase, and save it. Correct. And then the second if statement is going to do the exact same thing, but lowercase, and start one position and stay on one. So it's like you'll start at 2, and then you'll skip 3, and you'll lowercase 4, you'll skip 5, and lowercase 5. So you're basically, the only difference really is going to be where you start. That's how you're working. So, you're okay.
Because I still like the word dot add.
Yeah, so basically you will have 2 for loops. This is good. I just did a separate, but it doesn't really matter. You can have, as long as you have them both, you'll be good. So,
I know that one. that's right. So, okay, you're actually not checking for anything, so you don't need, you don't need the instinct, I don't take the card out. So, it's really I did it kind of working, it's all one line. That's basically what it is, so, mine is just called redistribution, whatever. String not that high, is gonna be assigned. That character, I'm gonna string it no matter what the other one is, character. In fact, it's not working for me. The string.
I'm stuck on
First element. Casting a character, storing it back to the exact same index as you took it. So basically, yeah. And then it's going to be by the way, like number size plus the that means
That line and then go to the next line.
So I did the exact same thing for the second one, just running the function. So I offset by what is now. This line is the first one and the third one. The first one is the second, the third is the sixth one. This one is the exact opposite. Starts with 2, 6, 3.
How much you have to use mod on, like you want to divide by 2 on one of them because you want to make sure that it's a different number. So that, yeah, so that you would make sure that you start with 0 and then go to 2 and then 4, 6, so on. In the straight that comes in, so it's always like uppercase.
Even?
Because it's just gonna start with an uppercase letter and then every other letter is uppercase.
Well, I mean, not necessarily, I mean, it starts with whatever, but, or any letter.
No, because uppercase the first letter, lowercase the second, so.
Right.
Yeah, so if you use mod for 0, 2, 4, 6, and so on, because you want all these even ones to be uppercase. Right.
Yeah, I mean, I see what you're saying. I don't know if that necessarily matters. I mean, yeah, oh yeah. Yeah, it works. So, I don't have any errors and I did style check and all that stuff. But basically, because I'm limited by the size of the string, this goes until it's done. And then this one does the same thing, it goes until it's done. It's just the only difference is where I started and they're both meaning by 2. So they're not touching each other.
So you have an if statement just saying, as long as the string is empty, we'll start.
Yeah, they're both, guided by that. And then, you just gotta do a for loop for basically the odds. And then I just, I do the exact same thing. And then, of course,
So static cast, you're forcing it.
Yeah,
You're making sure it's a character.
Correct.
You're making sure that when the string comes in, it's a character, so if he tries to put in a number, it will be a character.
In fact, I'm not even positive that this returns a character. You use string.i, I don't know that that returns a character. I think that returns whatever's in like an integer. So I'm saying we're reading a float.
Yeah.
It's not necessarily going to be a character. It's not read as a character. And then the 2 upper just represent, not cast as a character. I think it.
How do you make sure it's the first part of the string and then like the other, every other letter?
That's my I here. So the I starts at 0, so no matter what, this particular.
Oh, yeah, so it's always start at 1, so it starts from.
This one starts 1 past it and still.
Because you're increasing it by 2.
Correct.
So it goes 1, 3, 5, 7.
Exactly. This one does only odds, this one does all the evens.
Yeah.
And they're all limited by the size of the string.
Yeah.
So it works. I mean, I haven't had any issues.
When you're static casting it, so it has to be a character.
Yeah.
So did you put on the whole thing of like one big swoop or one statement?
Are you testing the unit test?
Yes.
No, I was gonna ask a question.
I don't know, I got most of the new styles. But I don't know what he's even talking about.
As far as what?
Like, do you like the expression and then put like all your loops and like this thing?
Oh, okay, well, that's why I don't know.
It takes you out of the.
No, it might not be me.
Oh, yeah.
I'm sorry.
I was trying to do it,
Nice, let's scroll to the called unit.
Oh, no, you're good. It's hard to keep track.
Because when I try to run the unit test, what happens is it tells me the errors when I just, all I do is write. Oh, sorry. And I didn't find. Did you say count characters?
It's a new line character.
Yeah, it
Wow, there
does.
you go. So now, this one's good.
That's what the dot H is, the sign underscore dot H.
Yeah,
That's where your prototypes are.
yeah, I put that.
Okay. And then you have to have all your inclusion there as well.
But,
I don't even know if I'm using all these. Whatever.
when you, run the file, you don't run, like you don't do like, assignments.
Well, you have to say you got,
You do, / unit test.
Not slash, but yeah, make space unit test, unit underscore test.
Mine doesn't even compile, it tells me it's
Instead of that,
unit test that I have not even touched. Like it's telling me that it cannot compare a pointer with an int or something. Something that I discovered is that the functioning has to be exactly the same as unit test. And I just had like one lowercase and one thing, and just completely screwed up.
Yeah, I'll probably need to test that. So if I try to make unit test, gives me a bunch of errors here. Tells me comparison between signed and unsigned.
So that's super easy to fix.
Yeah, I mean, then it gets worse. Then it starts saying invalid conversion from int pointer to int. And then it says another bad conversion from int pointer to int. And then it says int pointer in again. It just keeps saying that.
Your find value.
Mm-hmm. And I didn't write, like, before I even had all this, I go to the .h file. I just put the declarations in here, and then I put my inclusion stuff, and then I had these, and I didn't write anything in, where is it, find max value.
Errors, it'll give you what?
Am I supposed to write something for it to compile? Because, I mean, they're blank.
I don't think so. I mean, you'll get warnings saying that, this is,
yeah, but
these
now
aren't
I'm
being
getting
used.
errors saying that they're trying to compare pointers and integers.
If you're compiling it with unit test, that might be why. Maybe he's literally trying to. Are any of these by reference? No.
Usually it says pointers, it's really talking about your array.
Well, it says invalid conversion from int pointer to int.
So you're probably comparing your array to something as opposed to your array at an end.
I mean, okay, hold on.
Maybe.
Oh.
Okay.
Hold on a second.
In the, your header.
Let me see here. Delete this.
Because mine did that too.
Yeah, and I mean, I can just delete like all this.
Well, yeah, it has to be how you set it up.
Yeah.
So if we look at, so it's looking for this, like find max value.
Yeah.
So find max value, you did the size of.
Oh, I didn't put the brackets, did I?
Yeah.
Yeah.
Right?
That's probably
So
it.
there you go. Yeah, you forgot the square bracket.
Yeah.
Forgot it.
Yep.
Got it in the header. And
Yep.
in the-
I gotta go change the declarations too. It might fix that. Okay, let's try that.
That's why you just don't have, well, you just have that one.
It's not allowed here.
Well, because before it's like, I don't know what string is, right? And so it freaks out. Now I know what string is, and so
ID returned 1 exit status.
It doesn't like poorly. Oh. Oh, no. A copy and pasted from the count characters from the variable.